Hello everyone, welcome to our new video in Statistics and Probability. Again, this is Sir Neil, and on this video, I will be discussing about Lesson 1 on your Module 2, which is Understanding the Normal Curve Distribution. So to know more about our topic, let us answer the following question. What is normal distribution? Normal distribution is a special type of probability density curve that describes the tendency for the data to cluster at the center. It may sound unfamiliar, but it looks like this. If you see, it's a curve. With this shape, the normal distribution is also known as normal curve or bell curve. As you see, it looks like a bell. Now, to know more about normal distribution, let us further discuss about its properties. First up is the normal distribution curve is bell-shaped. As we have seen on our previous image, normal curve or normal distribution is bell-shaped. Next here is the curve is symmetrical about its center. Actually, it means like this. Symmetrical in a way that if you divide the curve into about its center, you will have two identical parts. The left side of the curve and the right side of the curve. When I say identical, they are actually equal. As you see, they are the same. This one, the left side and the right side. So they are symmetrical about its center. Next, the mean, the median, and the mode coincide at the center. It actually means that the mean is equal to the median and equal to the mode. The three of them have the same value, which is at the center of the distribution. Must be at the center of the distribution. Okay? So it will be a normal curve or a normal distribution if the mean is equal to the median and also equal to the mode. Okay? Next, the parameters mean in symbol of mu and standard deviation, which is in symbol of sigma, completely characterize the curve. When we say completely characterize the curve, these parameters or measures actually identifies the curve. Now, it looks like this. The mean actually identifies the position of the curve. If we move it to the right, we actually increase the mean. And if we decrease the mean, it moves to the left. So it determines, right? It is responsible for the movement of the curve from left to right. Okay? That is how the mean characterizes or identifies the curve. Next here is standard deviation. It actually is responsible for the spread. When you say spread, how wide or narrow the curve is. So if it is narrow, you see it's not that high. But if it is narrow, it looks like this. It's greater in height. Now, it's wide if it has a value of a large standard deviation. So it becomes narrower if you decrease the standard deviation. Now, given this, that these measures actually determines the curve, we have this special type of normal curve, which is standard normal curve. So when you say standard normal curve, from the word standard, this will actually become our basis to solve problems involving normal distribution. So it actually means that it is a normal probability distribution that has a mean value equal to 0 and standard deviation equal to 1. So as you see, if you remember, mean is actually at the center and standard deviation equal to 1, which is responsible for the spread. So it will look like this. If you see, 0 is at the center. And since our standard deviation is equal to 1, then we add 1 for each deviation in our distribution. So as you see, we have here 1. So the next would be 2, since we have 1 unit standard deviation. Every deviation is 1 unit. And the next would be 3. The same way here, we have -1, -2, and -3. Okay? So this is what we call standard normal curve. Okay? So let us take the next property of a normal curve. So the area under the normal curve is equal to 1. What we mean by that is actually like this. All the area, this shaded part, is equal to 1. It can't be over 1 or below 1. The total area inside of this is equal to 1. It can be lesser than 1 if it is fragments, but if the total, we are talking about the total area under the normal curve, that is equal to 1. Okay? And lastly, we will have the curve is asymptotic to the baseline. So as you see on the figure that we have, this curve actually meets the base. However, since we are talking about normal distribution, this doesn't actually meet. This curve actually extends indefinitely to the left and approaches the baseline, yet it doesn't meet. That is what we call asymptotic to the baseline. The same way on the right, it extends to the right indefinitely, but never reaches the baseline. It just approaches indefinitely. Okay? So those are all the properties of the normal curve. We will be discussing more about normal curve or the normal distribution on our next videos. So check out the new videos that I will be uploading. This would be all. Thank you. God bless and keep safe.